Subject utilization of electric power, module 2, illumination. First of all, starting the illumination, some definitions must be noted. That is the first of all candela. It is the unit of luminous intensity of a source. It is defined as 1/60th of the luminous intensity per square centimeter of a black body radiator at the temperature of solidification of the platinum, that is 2045 Kelvin. A source of one candela CD emits 1 lumen per steradian. Hence total flux emitted by it allowed is 4 pi into 1, that is the 4 pi lumen. Second definition of luminous flux, it is denoted by F or Fly. It is the light energy radiated out per second from the body in the form of luminous light wave. Since it is a rate of flow of energy, it is short of power unit. Unit of luminous flux is lumen, Lm. It is defined as the flux content per unit solid angle of a source of 1 candela or standard candela. Standard candle. 1 lumen is equal to 0.0016 watt approximate. Luminous hour, it is the quality of light deviated in 1 hour by a flux of 1 lumen. Luminous intensity I or candle power of a point source in any particular direction is given by the luminous flux radiated out per unit solid angle in that direction. I is d phi by d omega. Omega is solid angle. Now, utilization factor or coefficient of utilization eta. It is basically the ratio of lumens actually received on working plane to the lumens emitted by the light source. This is depend upon some factors. Number one, the type of lightning system. That means whether it is direct lightning or indirect lightning. Number two, type and mounting height of the fittings. Number three, color and surface wall and ceiling. Number four, some extent on the shape and dimension of the room. Depreciation factor. Depreciation factor is the ratio of illumination under actual condition upon illumination when everything is perfectly clean. Now, putting all the formula and equate, it is phi is equal to flux is equal to EA upon eta P, where E is the illumination in lumen per meter square, A is the surface area in meter square, P is the depreciation or maintenance factor, and eta is the utilization factor. Now, we are going some kind of lamp. First, in the first figure, it is sodium vapor lamp. It is abbreviated as LP vapor lamp. LP vapor lamp is consist of this U-type cylinder, and here in this cylinder there is the it contains sodium, neon gas, and 1% argon. And this U-type cylinder is enclosed via by this protective glass, and there is a connection is taken from this tube, U-type tube, and it is connected across a inductor, and there is the capacitor which is connected across the parallel of the supply. Here the supply is made. That's why here the supply is made to the supply. In parallel there is the capacitor. Capacitor improves the power factor of the supply. Then the voltage is grows up with the help of this inductor. This high voltage is required for discharge of the gas. There is, I already said that neon gas, argon gas, and sodium vapor is vaporized in this medium. If there is a potential breakdown of the medium, it gives a yellow light. It is named so sodium vapor lamp. The next one is high pressure mercury vapor lamp. This mercury vapor lamp, this is the tube. This tube contains mercury. This tube contains mercury and some certain amount of argon gas. Okay. There is the electrode, two electrode, and there is the bypass with the resistance of the air R. Generally, the value of R is 50 ohm. It is connected across the choke for increase the value of the voltage, and there is the capacitor. Capacitor is placed in parallel to the supply. A supply is given. So here supply is given, the power factor of the supply is improved with the help of this capacitor. The voltage is increased by with the help of this choke. At the starting, all of the gas, dielectric breakdown of the gas is not occurred. In that portion, dielectric breakdown occur between this part, that is the DS. Dielectric breakdown occurred between D and S, and then current flow through this resistance. After that, this dielectric breakdown occur, whole of the gases and mercury vapor present into this tube, and then the direct current passes to D to E, because current always follow lowest resistance path. So when this conduction has started, there is a no role of this resistance, and this portion gives greenish blue light. Greenish blue light is provided by this mercury vapor lamp. And finally, there is the fluorescent lamp. Here, fluorescent gas is poured in this tube, uh, and high voltage is developed with the help of this choke. Initially, there is no breakdown of the fluorescent gas, and that time there is the role of the starter. Current passes, supply, there is a supply, AC supply. Across the AC supply, there is the capacitor to improve the power factor. After that, the supply is go to the choke. Choke is the inductive coil which increase the voltage, and there this path is followed. After that, dielectric breakdown of the fluorescent occurred into this A to B, and in that time there is the this make the shortest path, and there is the no role of this choke, and this glass provide across white light. So this is the construction of the fluorescent lamp. Finally, we are going to the design of a hall. Here you can see that a drawing hall in engineering college is to be provided with a lighting installation, and the hall specification is given. The hall specification is 30-meter length, breadth is 20, and height is 5. But the mounting height of the light is 5 meter. Here given. Required level of illumination is provided. 144 lumen per meter square is given. Utilization coefficient is given 0.6. Maintenance factor is given 0.75, and height space height ratio is made 1. And you have provide two type of lamp. One lamp 300 watt, 13 lumen per watt, 500 watt lamp 16. In this type of problem, there is certain number of steps. First step is you should calculate space height ratio. Here space height ratio is make 1 and height is 5. So space is a space by 5 is equal to 1, that is the space is also 5 meter. So the space means the difference between two light should be maintained 5 meter. Second step is calculation of flux phi. Phi is EA by eta P. Putting the value, here E value is 1